This is an AS FP1 question using the t-formulae. Part A, we need to use the substitution t is equal to tan x over 2 to show that the equation 5 sin x plus 12 cos x equal to can be written in the form 7t squared minus 5t minus 5 is equal to 0. Okay, so if we have been given that t is equal to tan x over 2, that means that sine x is going to be equal to 2t over 1 plus t squared. So you'll need to know these, memorize these rather than try and derive them in a question like this. And also know that cos x will be equal to 1 minus t squared over 1 plus t squared. So always state those first, and then we can just substitute them straight into the formula we have here. So 5 sin x, so 5 times by 2t over 1 plus t squared, plus 12 times by cos x, and that's 1 minus t squared over 1 plus t squared is all equal to 2. We'll expand the bracket, so we'll have 10t over 1 plus t squared plus 12 minus 12t squared over 1 plus t squared is equal to 2. So we've got the same denominator in both, so we can put those together. So we've got 10t plus 12 minus 12t squared all over 1 plus t squared is equal to 2. We can times both sides by 1 plus t squared. So we'll have 10t plus 12 minus 12t squared is equal to, so we're going to multiply basically this by 2. So we'll have 2 plus 2t squared. Now we'll collect the like terms. So I've got 2t squared here. So I'm going to add 12t squared to both sides. So I'll have 14t squared. Basically bring the 12t squared over to the right hand side. The 10t is going to become minus 10t. Moved over to the other side. Now I've already got a 2, so I'll take away 12, so it's going to give me negative 10 is equal to 0. The whole lot can be divided by 2, leaving me with 7t squared minus 5t minus 5 is equal to 0 as they require. Part B, hence solve for x in the range from negative 180 to 180, the equation 5 sin x plus 12 cos x is equal to 2, giving your answer to 1 decimal place. Whenever you see the word hence, always look back at what you've just done to help you. Look at the range of solutions we need to give, that's important, and we need to give our answers here to 1 decimal place. So we're not going to attempt to solve this equation here with sine and cos. What we're going to do is solve the t equation that we know, or we've just proved the sine and cos equation can be written in this form. So let's solve this for t. So 7t squared minus 5t minus 5 is equal to 0. I'm going to solve this on my calculator. I can solve it using the quadratic equation. Now with the quadratic equation, you know it's always going to give you exact answers. If you get a decimal answer on your calculator, it might be worth just using the quadratic equation just to check that there isn't an exact solution. This one does have an exact solution, and we get 5 plus or minus the square root of 165 over 14. So those are our value of t. So now we can substitute that into the t equals tan x over 2 equation. So we have 5, let's start with the plus first. So 5 plus root 165 over 14 is equal to tan x over 2. So from here what I'm going to do is do the tan inverse, or arctan, to both sides. So if I do the tan inverse of, let's write that down, 5 plus root 165 over 14, that's going to give me x over 2. Now it might be a good idea at this point to change my range to x over 2, because I'm going to be using the cast diagram, see if I get any other solutions besides what I get on my calculator. So if I divide everything here by 2, I'll get a range of negative 90, x over 2, and 90. So when I'm looking for other solutions, this is going to be the range of values that I'm going to be using here. So let's see what we get for x over 2 from our calculator, and that's 51.8849. Okay, let me draw this on a cast diagram to see if I get any other solutions for x over 2. So I'm looking between 90 and minus 90, so I only want solutions that are basically here. I've just got this solution of 51.88, so it's here like this. With tan you draw a straight line. Okay, so I can see there's no other solutions in the range that's required, so I've just got the one for x over 2. Now I'm going to take the other value of t and see what value of x that gives me. So when t is equal to 5 minus root 165 over 14, let's see what we get for x over 2. And that's negative 29.2651 and so on. Again, quick cast diagram just to check if there's any other solutions. So between 90 and minus 90, I'm only looking for solutions over here in that range. Negative 29 is going to be like over here somewhere. Okay, with tan we draw a straight line. Okay, there's no other solutions in that range, so I can go ahead and multiply these values by 2 to get my values of x. So I have 103.76998 here, and then my other value of x, if I times this by 2, is negative 58.53025. Now it said I need to give answers to one decimal place, so I'm going to have x is equal to 103.8 degrees, and the other solution rounded to one decimal place is going to be negative 58.5 degrees. So negative 58.5 degrees, and we'll just highlight that. That completes this exam question.